Welcome to our video about supercomputers. Supercomputers are the most advanced and powerful computers on the planet. They are designed to handle massive amounts of data and perform complex calculations at lightning-fast speeds. These machines are used for a wide range of applications, from scientific research to weather forecasting and financial modeling. In this video, we'll explore the world of supercomputing and discover what makes these machines so powerful. First, let's define what a supercomputer is. In simple terms, a supercomputer is a computer system that is significantly faster than any other computer in its class. The speed of a supercomputer is measured in floating point operations per second, flops, which is a way to measure the number of mathematical operations that a computer can perform in a given time. Currently, the fastest supercomputer in the world is Fugaku, located in Kobe, Japan, and it can perform over 400 quadrillion flops. So what makes a supercomputer so powerful? There are several key components that contribute to the speed and performance of these machines. One of the most important factors is the number of processing cores. A processing core is a central processing unit, CPU, that performs calculations. Supercomputers typically have thousands of processing cores, which allow them to perform many calculations at once. Additionally, supercomputers often use specialized hardware, such as graphics processing units, GPUs, and field programmable gate arrays, FPGAs, which are designed to perform specific types of calculations more efficiently. Another key factor that contributes to the power of a supercomputer is the amount of memory, RAM, that it has. Supercomputers have hundreds of gigabytes or even terabytes of memory, which allows them to store large amounts of data and perform complex calculations. The speed of the memory is also important, as a fast memory can significantly improve the overall performance of the system. The interconnect is another critical component of a supercomputer. The interconnect is a network that connects all of the processing cores and other components within the system. It is responsible for transferring data between different parts of the system and ensuring that all of the processing cores are working together efficiently. High-speed interconnects are essential for supercomputers, as they allow the system to perform many calculations at once without slowing down. Finally, supercomputers also require powerful software to run. This includes operating systems, compilers, and scientific libraries. The software must be able to take advantage of the specialized hardware and massive amounts of memory in the system, and it must be able to manage the complex interactions between the processing cores. Supercomputers have a wide range of applications, from scientific research to weather forecasting and financial modeling. In scientific research, supercomputers are used to simulate complex phenomena, such as weather patterns, climate change, and nuclear reactions. In weather forecasting, supercomputers are used to process large amounts of data from satellites, weather stations, and other sources to produce highly accurate forecasts. In financial modeling, supercomputers are used to analyze large amounts of financial data and perform complex calculations to generate investment strategies. Supercomputers are also used in many other industries, including energy, pharmaceuticals, and aerospace. In the energy industry, supercomputers are used to model and optimize the performance of power plants and oil rigs. In the pharmaceutical industry, supercomputers are used to simulate the interactions of drugs with the human body, which can help in the discovery of new treatments. In the aerospace industry, supercomputers are used to simulate the performance of aircraft and spacecraft, which can help in the design and testing of new vehicles. Supercomputing is an exciting and rapidly evolving field, with new developments happening all the time. As technology continues to advance, supercomputers will become even more powerful and capable of solving increasingly complex problems. One of the latest developments in supercomputing is the use of artificial intelligence, AI, and machine learning, ML. These technologies allow supercomputers to learn from data and make predictions based on that data. For example, a supercomputer could be trained on large amounts of climate data to make predictions about future climate patterns. This could help scientists and policymakers make more informed decisions about how to address climate change. Another exciting development in supercomputing is quantum computing. Quantum computing is a new type of computing that uses the principles of quantum mechanics to perform calculations. Unlike classical computers, which use binary digits, bits, to represent information, quantum computers use quantum bits, which can exist in multiple states at the same time. This allows quantum computers to perform certain types of calculations much faster than classical computers. While quantum computing is still in its early stages, it has the potential to revolutionize many fields, including cryptography, chemistry, and finance. In cryptography, quantum computers could be used to break codes that are currently considered secure. In chemistry, Quantum computers could be used to simulate the behavior of molecules, which could help in the discovery of new drugs and materials. In finance, quantum computers could be used to solve complex financial models, which could help in the generation of investment strategies. One of the challenges of supercomputing is ensuring that these systems remain reliable and secure. Supercomputers contain vast amounts of sensitive data and perform critical calculations, so it is essential that they are protected against hacking, data breaches, and other types of cyber attacks. To address these challenges, supercomputer manufacturers and operators are implementing robust security measures, such as firewalls, encryption, and access controls. Another challenge of supercomputing is ensuring that these systems are energy efficient. Supercomputers consume vast amounts of energy, which can result in high operating costs and a significant carbon footprint. To address these challenges, supercomputer manufacturers are developing more energy-efficient hardware and software, as well as exploring alternative energy sources, such as renewable energy. Finally, supercomputing is also facing a skills shortage. As the demand for supercomputing continues to grow, there is a growing need for individuals with the skills and expertise to design, build, and operate these systems. This includes individuals with backgrounds in computer science, mathematics, physics, and engineering. To address this challenge, universities and organizations are offering training and education programs to help individuals develop the skills they need to work in the field of supercomputing. In recent years, the use of supercomputing has also become more accessible to researchers and organizations around the world. This is thanks to advances in cloud computing, which allows organizations to rent access to supercomputing resources on demand. This means that organizations no longer have to invest in expensive hardware and infrastructure to access supercomputing power. Instead, they can simply rent access to the resources they need, when they need them, through the cloud. This has made supercomputing more accessible and affordable for organizations of all sizes and has helped to drive innovation in many fields. In conclusion, supercomputers are the most powerful computers in the world and are used for a wide range of applications, from scientific research to weather forecasting and financial modeling. As technology continues to advance, supercomputing will become even more powerful and capable of solving increasingly complex problems. With the rise of cloud computing, supercomputing has become more accessible and affordable for organizations of all sizes, helping to drive innovation in many fields. However, there are also challenges that must be addressed, such as ensuring reliability and security, promoting energy efficiency, and addressing the skills shortage. Despite these challenges, the future of supercomputing is exciting and full of potential, and it will play a critical role in solving some of the world's most pressing problems.